Welcome to this exploration of green engineering, a critical field shaping our future. This discipline is more than just a concept, it is a fundamental shift in how we approach design and innovation. Understanding its principles is essential for every aspiring engineer. Green engineering, also widely known as sustainable engineering, focuses on the thoughtful design, creation, and operation of engineering systems and products. Its primary objective is to minimize environmental impact across all stages. A crucial secondary goal is to actively promote long-term sustainability in every project. This field employs a holistic approach, considering the entire life cycle of a product or process. This comprehensive view spans from the initial raw material extraction all the way through to its eventual disposal. The aim is to significantly reduce pollution, conserve vital resources, and ultimately protect human health. At its foundation, green engineering places a strong emphasis on pollution prevention. It prioritizes preventing waste generation at the source, rather than dealing with it after the fact. This contrasts sharply with traditional end-of-pipe solutions, such as filtration or treatment, which address pollution only once it has occurred. Another core principle is resource efficiency, which encourages the judicious use of all materials and energy. This includes promoting the use of renewable resources whenever possible. The selection of sustainable materials is also paramount in green engineering practices. Examples of sustainable materials include those with significant recycled content, reducing the demand for virgin resources. Bio-based materials, derived from renewable biological sources, are also highly valued. Furthermore, materials with low embodied energy, meaning less energy was consumed in their production, are preferred to minimize environmental footprint. Green engineering is inherently interdisciplinary, encompassing a wide range of traditional engineering disciplines. Its principles are applied across chemical engineering, civil engineering, mechanical engineering, and electrical engineering, among others. This broad applicability highlights its universal relevance. Innovative solutions are being developed in numerous specific areas. In renewable energy, green engineers design and implement advanced solar energy systems, harnessing the power of the sun. They also develop efficient wind energy systems and explore geothermal energy systems, tapping into the Earth's internal heat. Waste management is another critical application area. Engineers develop efficient waste reduction programs, aiming to minimize the amount of waste generated. They also create sophisticated recycling programs and design effective composting programs to divert organic waste from landfills. Water conservation efforts benefit greatly from green engineering. This includes designing water-efficient irrigation systems for agriculture and landscaping. Greywater recycling systems are developed to reuse water from sinks and showers for non-potable uses. Furthermore, advanced water treatment technologies are continuously improved to ensure clean and safe water supplies. Sustainable transportation is a rapidly evolving field within green engineering. This involves developing electric vehicles to reduce reliance on fossil fuels and improve air quality. Efforts also focus on improving the fuel efficiency of conventional vehicles and promoting robust public transportation networks to reduce individual car usage. Green buildings represent a holistic application of these principles in construction. Engineers design energy-efficient buildings that minimize heating and cooling demands. They also focus on utilizing sustainable materials in construction, from recycled steel to rapidly renewable bamboo. Optimizing resource use within buildings, such as water and electricity, is a key design consideration. The advantages of adopting green engineering principles are multifaceted, spanning environmental, economic, and human health domains. Environmentally, it contributes significantly to a healthier planet by actively reducing pollution across various sectors. It also plays a crucial role in conserving natural resources, ensuring their availability for future generations. Economically, green engineering offers substantial benefits. It often leads to reduced operating costs over the long term through increased efficiency and lower resource consumption. Furthermore, it creates new markets for sustainable products and services, fostering economic growth in environmentally responsible sectors. This approach also stimulates innovation, driving the development of new technologies and processes. From a human health perspective, green engineering directly improves well-being. By minimizing exposure to harmful chemicals in products and processes, it reduces health risks. It also works to minimize exposure to pollutants in air, water, and soil, leading to cleaner environments and healthier communities. Implementing green engineering practices does present certain challenges. It requires a significant shift in mindset from traditional engineering practices, moving away from linear models to more circular, sustainable ones. This approach demands a more holistic and long-term perspective, considering impacts far beyond immediate project completion. While often yielding long-term savings, green engineering may involve higher initial costs for sustainable materials or advanced technologies. Overcoming these upfront investment hurdles is a common challenge. However, these costs are increasingly offset by long-term operational efficiencies and regulatory incentives. Despite these challenges, the driving forces behind green engineering are powerful and growing. There is an increasing global awareness of environmental issues, from climate change to resource depletion. This awareness fuels a rising demand for sustainable solutions across all industries and consumer markets. Technological advances are continuously reducing the costs associated with green engineering solutions, making them more accessible and competitive. Green engineering is therefore poised to play an increasingly crucial role in shaping a truly sustainable future for our planet. It is also vital in building a resilient future, capable of withstanding environmental and resource pressures.